Okay, now let's talk about the mean value theorem. The mean value theorem states that if f, a function, is integrable on the closed interval ab, so it includes the endpoints a and b, then the average value of f, the function, on the integral is 1 over b minus a times the integral from a to b of f of x dx equals f of c. So, there's a bunch of words and letters here. We're going to draw out a diagram. Let's do this. So say A is here and B is here, and let's say the graph is kind of like, takes a little dip here and then it goes up. So here's A, and here's B. So this is the area underneath the curve that we're trying to find. So this average value is some point f of c in which the height is perfect. That means that if you, let me find this height right here. So that means if you use the equation area equals base times height, if you use the base as b minus a times f of c, f of c is the perfect height. It will give you exactly the perfect area underneath the curve from A to B. See, this is structured a little bit differently because you can see that. Alright, so let's rewrite it and then let's solve it by using that. So what we're trying to find is this, and then we know that this is going to equal b minus a times f of c. So now, if we're trying to find this perfect height, we're going to divide by b minus a. So the way you divide by b minus a is you multiply by 1 over b minus a. So you end up getting 1 over b minus a times the integral from a to b of f of x dx equals f of c. So you can see where this formula comes from, and you can tell that there's some point c here in which, oh, it's not over here. Oopsie daisy. It's normally in the center on most problems that I have. Okay, there's some point c here in which this height is going to be perfect. Okay, so now let's solve an example problem. So here it's asking us for the average value of f of x when it equals 3x squared minus 2x on the interval 1, 4. So when I have a problem like this, I normally just take the formula and I start plugging stuff that I know. So we know that this 1 is a and this 4 is b. And we know that this function here is the function that's going to be inside of the antiderivative. So this is going to be 1 over b minus a, 4 minus 1. That's going to be the base of the rectangle, but you divide it, or you multiply 1 over b minus a. So times from a to b, 1 of 4 of 3x squared minus 2x equals f of c, the average value. So we can simplify this to be 1 over 3 times 1 to 4, 3x squared minus 2x equals f of c. So now, you could just plug this into your calculator, but what we're going to use here is FDC Part 1. Yay! So, let's just take this 3 out in front. So, the way you do this is you take the antiderivative first, and then you set up boundaries. So, the antiderivative of 3x squared is x cubed, and the antiderivative of 2x is negative x squared. And that should make sense, because if you take the derivative of these, you would get this. Now, let's set up the boundaries. So, 1 and 4. Now, let's plug 4 in for both of these and subtract it when you plug in 1 for both of these. So, you get 1/3 times 4 cubed minus 4 squared, and then subtract 1 cubed minus 1 squared. So 1 minus 1 is 0. This is gone. 4 cubed minus 4 squared, 1/3 times, this is 64 and this is 16. 1/3 times 48. So this means this number is 16. So this perfect height occurs when y equals 16. So now, the way if there was another problem following this, it would typically ask you at what value of x is this going to happen. So let me show you how to do that too. Just erase all of this. Okay, so we know that the perfect height is at 16. So f of x equals 16. So plug that in for the y, we get this. Now we just subtract it over to the other side. 3x squared minus 2x minus 16. And now I think I'm going to use my calculator to find what this perfect number is, because I don't think it solves nicely. So it ends up being x equals 8/3 and x equals -2. So let's see which one seems more reasonable. So let's go back to this interval 1, 4. So -2 doesn't fit in that interval, so we just cross it off. 8/3, on the other hand, that's a little bit under 3, because if 9/3 is 3, 8/3 is about 2.66. So that fits in the interval. So that means this is when the perfect height is. So it would be 8/3 16.